Hi everyone. In this video, let's solve lead code number 125, valid palindrome. So this is a really easy problem, but it gives a good introduction to a technique called as two pointers. So if you don't know what a palindrome is, so suppose you have a string, let's say race car, okay, and so a palindrome is basically a word or a string that reads the same way both from the left side and from the right side. So if you see there is left side is RACECAR, and even from the right side it's RACECAR, and uh, there are many other examples as well. So the first approach which anyone can come up with is basically sorting. So essentially, what we do is we just simply check if the str1 is equal to uh, or okay, I mean, pardon me, we don't sort it, but rather we reverse it. I've been doing a lot of sorting questions, so it comes in my mind. So we just reverse the string. So in Python we can just do uh, this minus one. So or then this, and it just reverses the string. And if the string one and the reverse of the string are the same, then we return true. Else we just return false. So this is one of the approaches, and if you can observe the time complexity for this, be something like big O of and log n, because there's sorting involved in this, so that's why the time complexity big O of n log n, and the space complexity is big O of 1. So that's basically the sorting approach, and let's consider the more optimized approach. So this involves a technique called as two pointers, which I mean is quite intuitive. So let's try to understand it. So optimized. So I'll take a much better example probably. So just uh, take this example, right? So a man, a plan, a canal, and colon Panama. So okay, quite slow. Yep. So if I take this as a man, a plan, uh, a canal, Panama, right? So I would just write it in a single line because it becomes really easy to explain that way. So a man, comma, a plan, canal, Panama. Okay, so this is a string, and I mean, if you just read it from left to right and from right to left, right, so it spells out the same thing. So uh, basically, what we do here is we keep one pointer at L and one pointer at R. So the whole idea is that if you start from starting and if you start one point from the ending, right? So the letters always match in a palindrome. So here, since both L and R match, we just move both the pointers, okay, one forward, or so we move. this pointer here, this space, and this pointer comes to M. So basically, I mean, we we essentially have to avoid spaces here. Wherever we have spaces or uh, sp- I would say special characters. Mm, suppose I'm just marking all of them here. So what we basically do is, when we are at of a certain index, we basically check if is it's either an alphabet or a number. So using the is_num function, if it's not an alphabet or number, if it's a space or colon or uh, let's say like comma, and in that case we don't consider that and just move forward with skipping the special characters. So that's how we go about solving this question. So once you have a special character, we just go to the next uh, letter. So now I go to M here. So and then we compare both R. So R and L. So again, M is equal to M, right? So now we move both the pointers forward again in this way. Then this is an L, this is an R. They are the same, and then we move this here. Here we keep continuing and R. And now we have a comma, right? So we just skip it, and then move to a space. So the space also special character skip, go to A, and now A is equal to A, right? So we keep we keep doing this until at one point we find a middle point, midpoint, which basically L and R both end up in the same place. I'm not sure if this is the exact mid, but you can consider it that way. Somewhere at this comma, right? So once now what happens in the next iteration is that uh, R goes here, and then it basically crosses L. It crosses paths with L and goes to the first half of the string. So at that stage, we just kind of exit and return that it's a palindrome, because I mean, we have already checked the letters in the first half and in the second half, right? So they're matching. So we return it as a palindrome. And in any case, right, when we are moving, so if L is not equal to R, we directly return that it's not a palindrome and we don't have to check further. So the time complexity for this would be of n, because we just, in the worst case, we are just iterating once over the entire array. So each letter, um, you know, each letter is traversed only once, or we visit each letter only once. So the often is the worst time complexity, and space complexity is of one. So yeah, now coming to the code is really simple. So we have the L pointer here starting at 0 and the R pointer starting at the end of the string. So while L less than R, if S of L is not an alphabet or number, we keep we move L front and continue. Similarly for R as well, if it's not a number, we or an alphabet, we reduce R and then continue. Uh, if they both are alphabets or numbers, and if still L is greater than R, or uh, if basically S of L dot lower means the character at the L index is not equal to the character at R index, we return false. Else we just move our pointers forward and backward. So one thing to keep in mind, which I forgot to mention, is we'll always have to uh, check for like the lowercase, because sometimes it can be an uppercase like here, right? So P is capital here and P is small here. So always check the lowercase of the alphabet. So that's all for this video. I'll see you in the next one. Thank you.